Hello. Recently we've been working on looking at the polynomials and their associated graphs, looking at relative minimums, relative maximums, x-intercepts, y-intercepts, intervals of increase, intervals of decrease, and ultimately what we want to do is start to associate those with something a little more realistic. And so today what we're going to begin talking about is modeling with polynomials, and this is just an introduction. And so what we've got here is a box is to be constructed so that it has a square base and no top. And so this information is really, really important as we go through this. So this has a square base with no top. Details are going to help me draw a picture, and ultimately that's something I really need. So it says draw and label the size of the box, label the size of the base with x, and the height of the box as h. Well, the first thing I need to do is make sure that I have my square base. And so what this means is that side length is equivalent to that side length is equal to that side length is equal to that side length. And each of these values is going to be x. And so dimensionally we've got these x's, and then I need a height of h. So I'll draw my height up. Okay, and my final side back there. And this height is h. So what we've done as we were asked there. Part 2 says the surface area is 108. So if I'm not sure what surface area is, that's a great thing to kind of look up. But it basically is exactly what it sounds like. It's the area of the surface. Or covering. And so if I'm thinking about this in terms of what I need to cover the left side, the back side, the front side, the right side, and the bottom side. Notice I didn't say the top side because this is a box with no top, and that's why highlighting that can be really important. It says write a formula for the surface area and then solve for h. So my surface area is going to be equal to the right side plus the left side plus the back plus the front plus the bottom. And notice I didn't say top. And going through this, that labeling is going to be really helpful as we go through and try and find these. Well, the right side has dimensions of x times h. The left side, x times h. The back, x times h. The front, x times h. And remember, it's a box, so this length is going to be equivalent to that length. And the bottom is x times x. Let's just simplify this. I have 1, 2, 3, 4 x times h's plus x squared. Now, for some of us, we're used to this idea of solving for h. Others of us, maybe we have to give you a little bit of vocabulary that gives us a reminder. So maybe you've heard of this. It's called literal equations, and maybe you haven't. What it basically means is that we don't have numbers, but we are solving for one of the variables. The variable that I'm solving for is the h. And so I kind of have to link this back to something that I've seen before, such as like 4h plus, say, 9 equals s. And if I'm solving for the h, the first thing I'm going to do is get rid of the addition And so that's the same thing I'm going to do over here. So you want to try to connect the new problem to one that you've already seen before. So I get s minus x squared equals 4x times h. Over here I would have s minus 9 equals 4h. Well, now I have multiplication, so how do I undo multiplication? With division. And I have to divide everything on one side by 4 and everything on the other side. Well, it looks very similar over here, but I'm going to do the 4 and the x because that's what I'm multiplying by, and the 4 and the x. And so s minus x squared divided by 4x equals my h. And so I'm just going to circle this so I bring my attention to it later on. It's going to be important. So now I've solved for h. Letter C says, write a formula for a function of the volume. Well, if I remember correctly, volume is length times width times height. Well, my length and my width are both x's. X times x times h. H is s minus x squared divided by 4x. And you've got to remember that you're substituting. Okay. Now what I notice is that I have an x in the numerator and x in the denominator, so what I can do is make a 1 with that. So this is equivalent to 1. It just simplifies my expression a little bit for me, and now I have x on the outside of s minus x squared divided by 4. And we can distribute that in, so my final equation is s times x minus x cubed all over 4. And so now I've written the formula of the volume in terms of x. I'm going to box that. And then it says use a graphing utility to find the maximum volume of the equation. So if I look at my graphing calculator, there are a few things you want to analyze. One, the domain is in terms of what is useful to you. And basically it looks a little bit like this. Kind of comes down, back through 0, up, and back down. So here's the sketch of the graph. When we get back to the vocabulary, it's not really asking for the true maximum, because as you can see, this will go on to infinity. What it's really asking about is this relative. And it's really thinking about this in terms of problem itself. This is just past 10, so here's 10. This is just under, that's negative 10. Okay. And if you use Desmos, this is really kind of a nice feature. You can actually put a point right on there, and that point is going to be 608. Now, you might be wondering why we're ignoring every other number. Well, we're working with a box, so the only values that would make sense for the dimensions of the box would be positive numbers, first of all. And then essentially you cannot have a negative volume, so you ignore it. So really all I'm looking at is this area of the curve describing the volume. Okay, and the range of numbers that I can work with go from 0 for the x, because we need some sort of value here, and it maxes out just past 10. Okay, and so what dimension should the box be in order to maximize its volume? Well, you have the x value right here. It's 6. And so you have to do a little bit of substitution, but x is equal to 6, so my length equals my width equals 6. The other value you need is the height. So you have to come back to this equation and substitute it in. So the maximum volume, or height, is based on the surface area, which is 108. So really all these could have been turned into 108s with substitution. And so now I have 108 minus x squared is 6 divided by 4 times 6. So 108 minus 36 divided by 24. 108, so 8 minus 6 is 2. That's 72 divided by 24. And that is 3. So h is equal to 3. So length and width, 6. Height is 3, so I get a 6 by 6 by 3 dimensions. So again, you might want to pause your video at various spots. You might want to rewatch it. Make sure you understand why I was able to put the 108 in there. I'll bring back a highlighter and make sure that we put the surface area. I did a very general formula. And so really, ultimately, I could put any number in, but in the end, I needed the 108. So make sure you understand why I was able to put the 108 in there. That allowed me to put this formula in Desmos, so understand that this is a Desmos instruction, or you could use your graphing calculator. We used not just a maximum, but a relative maximum. And ultimately, the discussion, when we're starting to do modeling, talks about like what is a realistic value for each of the dimensions. Okay? Please summarize, write down any of the vocabulary that you need. Thank you.